Okay, we're going to talk just briefly about the nomenclature of alkynes in this video. So we name alkynes almost exactly the same way that we name alkenes. In fact, it's almost probably easier because I don't even have to worry about E and Z isomers. So just like naming another compound, we identify the parent chain. Just like alkenes, the parent chain has to include our carbon-carbon triple bond. We identify and name the substituents just like we would for any other compound. When we decide how we're going to number it, just like alkenes, we want the carbon-carbon triple bond to have the lowest number possible. We list the substituents in alphabetical order, just like we would any other compound. And just like in alkenes, we have to give the location of the carbon-carbon triple bond, and we either put it right in front of the parent name or right before the YNE suffix. So I guess I didn't say at the beginning, and I should have, right? Alkenes end in ENE, alkynes end in YNE, versus alkanes, which end in ANE. Okay, so I'm not going to ask you to know any common names of alkynes, but I think it is important to know what acetylene is. So acetylene is basically the simplest alkyne. Acetylene is this compound. I think it would be good to know what acetylene is, but then if you see some of these common names, you'll probably be able to derive them. So we've got methylacetylene, diisopropylacetylene, or phenylpropylacetylene. I think if you know what acetylene is, you can probably come up with what these compounds look like. One other thing to know about the nomenclature of alkynes is they're also classified as internal alkynes, where we've got carbons next to the carbon-carbon double bond, or terminal alkyne, where we've got a CH bond coming off of the carbon-carbon triple bond. Okay, because the nomenclature of alkynes is so similar to alkenes, I'm just going to do two examples. So in this first one, we need to, like always, first identify what the longest chain is, but our longest chain has to include the carbon-carbon triple bond. So, right, my longest chain could be 1, 2, 3, 4, 5, 6, 7, 8, but that didn't include my carbon-carbon triple bond, so that's no good. So I think my longest chain is in fact going to be 1, 2, 3, 4, 5, 6, 7, and then everything else is going to be substituents. So I have a methyl, an ethyl, here's a straight chain 3 carbon, so that's going to be propyl. And so when I go to name this, the numbering needs to be so that the alkyne, the carbon-carbon triple bond, has the lowest possible number. So I'm going to start numbering here. So 1, 2, 3, 4, 5, 6, 7. So then putting all this together, putting in my substituents in alphabetical order, I have 4 ethyl, 5 methyl, 3 propyl, and then 1, and then 7 carbon chain. An alkane would be heptane, an alkene would be heptene, and so the alkyne is heptyne. Okay, so one more example. First, we identify the parent chain. Don't let this CCl3 confuse you, right? This is just a carbon with 3 chlorines coming off it. So I think my longest chain is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, whether I go up and make the 10 here or down here, it's not going to change it. So I have a decane. Now let's see what my groups are. So I have a trichloro, I have a dimethyl, and I have an ethyl. When I number it, the carbon-carbon triple bond has to be the lowest, so I'm going to number it as 1. All right, and I'll put my substituents in alphabetical order, but of course I don't include the di in the tri when I'm alphabetizing it, so my trichloro will come first. So I have to give a number for each one of the chlorines, so it's 1, 1, 1, trichloro. And the ethyl will be next. And then I'll finish it off with two. The alkane would be decane, so the alkyne would be decyne.